Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson, I am going to be describing sediment data in the two dimensions and using a 2D flow area. All right, so what I have on the screen here is the web page from the 2D RAS 2D sediment users manual. This right here is the page of data I'm going to be going through for this lesson. So I'll go ahead and leave a link to this page in the video description in case you want to read all the details. All right, so what I have already prepared in my HEC RAS is a 2D model. I'm going to go ahead and turn off the terrain layer so we can actually see the 2D flow area. There's the river, the bank lines, the cross sections, boundary lines, and the 2D flow area sketched out in this map right here. All right, so if we want to define sediment data, we've seen this a few times earlier in earlier lessons for 1D. What you're going to do is go up to Edit and then Sediment Data. This will bring up the sediment data dialog box. You can also access this dialog box by clicking on this button right here, SCD, and then boom, there we go. Now, what we have across the top are a number of tabs. This first tab is for initial conditions and transport parameters. I've already talked about this in my lesson 53. And then the next tab over is boundary conditions. I've already talked about this in my lesson 54. And then the next tab over, the B-stem data. This is specifically for bank process computations. It's not required for sediment transport. But what I want to talk about in this lesson is the fourth and final tab here, 2D bed gradations. How to define your bed gradations and assign those gradations and potential layering of gradations in the 2D flow area. What we see here at the top is a few different drop downs we need to specify values for. They already have default values, but maybe those aren't the ones you want. Starting with the transport function. Now, the transport function is used to determine the amount of sediment transported based on hydraulic conditions as well as sediment properties. So you can see our options in this drop down include Akers White. This one is developed for sand and fine gravel. After that, we have England Hansen. This is best for a uniform gradation. I'm not going to go through every single one and what it's best used for, but there is a pretty large variation in the sediment results based on the transport function you choose. So the user manual does provide more information about these different transport functions. All right, next one down is the sorting method. And just like transport function, we have a number of different options. This deals with the sorting, of course, of the sediment. After that, we have the fall velocity method, a number of options to choose from here. This is sometimes referred to as the settling velocity, and it refers to how quickly the sediment will settle in the water. So for instance, if you choose Ruby, this one is used for fine sediment and sand particles, but just go ahead and select the method that's most appropriate for your model, and the user manual does provide additional details on all of these methods. Over to the right, we have a couple buttons here, define and edit bed gradation, and then below that, define layers. And below that, the majority of this dialog box is this table here, which has a column for bed material type and then the gradation. So before we can really do this, it makes sense to go over to RAS Mapper, sketch out our classification polygons for a sediment layer, and then return back here to this sediment dialog box and make the appropriate assignments then. All right, so we're going to put this sediment dialog box on pause for just a moment. I'm going to go ahead and close that. Okay, so it's asking me for a name for the sediment file. I already have one called base, so I'll just call this base2 and then click OK. All right, so here we have RAS Mapper. What I'm going to do is right click on Map Layers, create a new RAS layer, and then Sediment Bed Material layer. Now you may already have a shapefile or a raster file containing bed material data. And if that's the case, you can just click on this plus button and then navigate to that file. But in most cases, you probably won't, in which case, what you want to do here to create this new sediment bed material layer is just to click empty layer, create empty button, and then you can also modify the cell size if you want. So let's go ahead and make it, say, 50 feet. All right, that's going to create a sediment bed material.hdf file. So we can go ahead and change the location of the file name of that sediment bed material layer if we want. I'll just go ahead and assume this default file name and file path, and then click on Create Empty. The Manage Layer Association box popped up for me here. Okay, there we go. Sometimes it needs to get resized. But over in this column for sediment bed material, it automatically assigns the current geometry, which is called base, which I created before the video, with this sediment bed material layer, which I've called sediment bed material. Okay, so we can go ahead and change this later, but let's just go ahead and stick with that. Making this assignment here for sediment bed material as my sediment bed material layer, it only associates the bed gradation layer with the geometry, not with the actual sediment file. Once we create the sediment file, it will inherit the bed gradation from the geometry file. So just a little bit of a nuance there, but it's mentioned in the user's manual. I thought I should mention it here as well. Now within map layers, I'm going to click the plus to expand and then check on sediment bed material, expand that as well. And now I have this classification polygons layer. If I want to go ahead and start editing that, I'll select it and then click the edit pencil, or I can just, let's see, if I stop the edits, I can also right click and edit layer, same thing. What I'm going to do is a very simple example. I'm just going to sketch out two areas in my 2D flow area. So I'm going to have like an upstream area right here. I'm just doing single left clicks and then a double click to stop. I'm going to call this classification name Polygon Upstream. You may call it something else, maybe my river station number or some other name, but just to be explicit in this lesson, I'm going to call it Polygon Upstream and then click OK. I'm still editing now. I'm going to go ahead and sketch out the downstream region. I'm going to get a little bit of an overlap here with the upstream region. That's fine. Double click and then give it a name. Instead of upstream, I'm just going to call this downstream and then click OK. All right. I'm going to go ahead and click stop to save the edits and say, yes, I want to save. All right, we've done the work we need to here in RAS Mapper. Let's go back to the sediment data editor. So edit sediment data. Looks like I already have my base 2 sediment that's already loaded up here. If I don't, I could just go file, open sediment data, and then click on base 2 and then OK. All right, so let's click on that fourth and final tab here, the 2D bed gradation. Now you can see in this table, we have the upstream polygon and downstream polygon just waiting for us to define its sediment properties. So before we do that, we need to do the tasks associated with these two buttons right here. First, define and edit the bed gradation. So I'll go ahead and click that. Now we've seen this in the lesson 53. Yes, lesson 53, but I'll just go through it again briefly. What we're doing here is defining a gradation. So I'll click this button here for new gradation. I'm going to call this fine sand and then click OK. Now what I want to do over here is define the percent finer. So this is the grain size distribution. I'll go ahead and say 50 and 100 and then 0 right here. Now to be complete, I could probably type in 100 in all these other rows and also type in 0 in all these preceding rows and then call it good. There's also a few other parameter data that you can enter, like cohesive data and then the 2D polygons, but we're just going to keep things simple. Now I want to create a few other gradations. So this one I called fine sand. I'm going to go ahead and click on, actually it'd be easier if I just click on the copy button. Next, I'm going to call this coarse sand and then click OK. Okay, so coarse sand is just going to be 0, 50, and 100. Okay. And then I'm going to add one more gradation. This is going to be called fine gravel. So click copy, fine gravel, and then the edits I'm going to make are just changing it one right there. Okay, so there we go. I've got my 3 gradations defined, and then let's click OK. Next, what I need to do is click on this Define Layers button. Currently, there are no gradation layer groupings. Press New, so we'll go ahead and do that. Defining layers is where the user specifies bed layer groups, which will be used to specify the vertical bed layers, each with specific depths and gradations. If I bring up that user's manual page that we saw at the very beginning, here's a diagram that the main bed material is associated with either a bed gradation or a non-erodible source. But what we're going to be doing here is this third option, bed layer group. This is the most detailed and probably the most realistic, where each bed layer group can have a number of layers, each with their own depth and each with their own gradation. And at the bottom, the very bottom, you'd have your bedrock or your non-erodible surface. So what I'm going to do is create a bed layer group, one for that upstream polygon, one for the downstream polygon, and then use some different depths and bed gradations for those bed layer groups. Okay, so let's go ahead and just see it in action. I think that'll make it a little bit more obvious. All right, so I'm going to go ahead and click the new layer button. I'm going to give it a name and I'm going to just type in or paste in the name upstream layer definition. You may have a better name for it, but that's what I'm going to do. Click OK. Now what I need to do is specify the number of layers. So I'm going to say we're going to have 3 layers. It gives me 3 rows in this table. The depositional layer thickness in feet, this is not used for 2D, so I'll ignore that. And then over here, I'm just going to go ahead and say there's 2 feet of a specific layer. We'll call it fine sand. And then below that, it's going to be 3 feet of our coarse sand. And then below that, we will say it is our non-erodible surface. The layer of this non-erodible surface is not used, but I just typed a 1 in there anyway. All right, so we basically have 5 feet of erodible material, 2 feet of fine sand, below that 3 feet of coarse sand. That's the depth, the vertical distance. Now I want to create another layer group for the downstream polygon. I'll click on this new button right here. I'm going to give it a name, but instead of upstream, just call it downstream layer definition. Okay. We will again say there's 3 layers. This time I'll say the top layer is 3 feet, and that is going to be, no, actually I changed my mind. Let's go with 4 layers. First layer is going to be 1 foot deep. This is going to be the fine sand. Below that, we'll have 2 feet of the coarse sand, and then below that, I'll have 2 feet of the fine gravel. Okay, and then of course we'll finish things off with a non-erodible surface. So this is a little bit different definition than we had for the upstream layer definition. This is what I'm calling downstream for the lower half of that reach, the lower polygon that I sketched in RAS Mapper. All right, so I'm going to go ahead and click OK. Now the last part, what we have to do here is select okay, it's only giving me non-erodible surface. I should be seeing the different gradations and layers listed here, and that's not a problem. I think what I just need to do is save, and then, okay, let me go ahead and close the sediment data editor and then open it back up. I think it just needs to refresh, so let's see what happens here. Edit, sediment data. I'm going to click on this tab for 2D bed gradations. Here are our polygons, and here, okay, good. Here is the list of gradations and layers. So for the upstream polygon, I'm going to click on upstream layer definition. And for the polygon downstream, it's going to be the downstream layer definition. After that, I'm going to go ahead and go File, Save Sediment Data, and we are all good to go. Well, that's it for this lesson. What we talked about was defining sediment data for a 2D flow area in HEC RAS.